ಹಾಕಿನ bit hole. So gated SR latch, here we have S and R as an input, NAND gate A and B, isn't it? So here you have S bar R bar latch. S bar R bar latch, it acts as a S bar R bar latch. Whenever the control signal is 0, here what happens? 0, whatever may be here, it will come 1, and here also 1 will come. So here, if suppose this control signal is 0, okay, so what will come here? Because whatever may be 1 or 0, what happens? 1 will come here, 1 will come here, and this Q will come here. Okay, so here due to the functionality of the NAND gate, so one NAND, if it is 1, you will get 0. If Q is 0, you will get 1. So if it is Q, so here you will be getting Q bar. Okay, so here you are getting the Q bar. Okay, if it is 1, you will get 0. You will give it 0, you will get 1. So you will get Q here. So if the control signal is 0, here I am explaining this. If the control signal is 0, irrespective of the inputs of this, it will retain the current state. The next state, Q plus bar will retain the current state, that is the present state. Okay. So similarly, if you apply combination 1 1, and when the control signal is 1, both the outputs will return to 1 and 1, which is unpredictable behavior, and which will return the S and R return to 0 simultaneously. Okay, so whenever S and R is 1 1, control signal is 1, the output will return to 1 1, which is not complementing each other, and hence it is known as an unpredictable behavior or forbidden state. Now next, when is S is 1 and R is 0, control signal is 1. Okay, so you will get the output 1 and 0. You apply 1 and 0 here. So what you will get here? You apply the 1 and 0 and understand this, you will get 1 and 0. This is a simple NAND gate construction. If you apply 1 and 0, you will come to know what will be the output of the A NAND gate and what will be the output of the B NAND gate. Okay, so you apply the inputs and check the outputs, you will get 1 and 0. Next, apply S is 0, R is 1, control signal is 1. Apply the input 0 to the S and R to the R1. You will get the output 0 and 1 at the Q plus and Q plus bar. Next, you apply SR 0 0, control signal is 1. That time it will retain the current state. Okay, so this is about the gated SR latch. What is the difference here is, there is a control signal here which makes the S and R input effective. Effective means whenever the enable signal or a control signal is 1, and if you change the inputs, it will reflect at the output side. If the control signal is 0 and you change the input, that will not affect at the output. That will be not reflected at the output side. So that is the difference between the normal S bar R bar latch or SR latch with the gated SR latch. D latch. In the gated D latch we have, if D is 0, that is the data latch. It is known as the data latch. If D is 0 here, clock is 1, that is clock means control signal is 1. That time Q plus will be 0, Q plus bar will be 1. Okay, when I apply 1 here, at the output also I will get 1 only, that is Q plus is 1 and this is 0. Okay, if the control signal is 0, if the control signal is 0, whatever may the D input, may be 0 or 1, it will retain the current present state. This is the functionality of this gated D latch. D stands for data latch. It is a transparent latch. It is known as a transparent latch because whatever you apply at the D input, that will be present at the output Q. Whatever, if you apply 0 here, you will get 0 only. If you apply 1 here, you will get 1 only. So this is the function table of the D latch. These are the symbols. Two ways are there to represent the symbols: D, C, Q, Q bar, and D, C, Q and Q with a bubble. So any doubts in this? Gated D latch. So here whenever D is 0, the output Q will be 0. Okay. Whenever D is 1, the output Q will be 1. Okay. So this is known as a transparent latch.